In this video, I'm going to do the parent function for cosine, which is y equals cosine of x. And that is the most basic cosine equation, which is why it's the parent function. In the last video, I converted all of these radians, these input angles, into degrees. But in this video, since I already did that in the last video, I'm going to plug in these radians, these angles in radians into this equation and see what I get for y. So I'm going to do the first thing I'm going to do is I'm going to look at the values from 0 to 2 pi on the unit circle. And I'm going to decide what the y value would be if I did cosine of these angles. So the first one that I'm going to do is for the radians, for 0 radians, which would be on the unit circle at the point 1, 0. And I know that if I'm looking for cosine of an angle, it's just my x value on the unit circle. So in this case, for this first angle of 0 radians, my answer would be 1. So I had the point 1, 0. This is my x value, so my answer is 1. For pi over 4, that is going to be the point square root of 2 over 2, comma the square root of 2 over 2. I'm looking at my x value there, and that's the square root of 2 over 2, which I can round to 0.7. Then for pi over 2, that's going to be this angle here. This angle here is got the point 0, 1 on the unit circle. And I know that the x value there is 0, so my answer would be 0 for y if I did cosine of pi over 2. And then if I did cosine of 3 pi over 4, I would be looking at this point for the x value. It's negative square root of 2 over 2, comma square root of 2 over 2. So it's negative square root of 2 over 2, square root of 2 over 2, or a negative 0.7. And then if I'm looking at to do cosine of pi, I'm looking on the unit circle at the point negative 1, 0, and the x value there is negative 1. And then if I do 5 pi over 4, it's this same point except with 2 negatives. So negative square root of 2 over 2 is the x value, and negative square root of 2 over 2 is the y value. I'm just concerned about the x value, so I have a negative 0.7 again. And then 3 pi over 2 is here. The point on the unit circle is 0, negative 1, so my x value is 0. And then I have the point for 7 pi over 4. That's in the fourth quadrant with the reference angle of pi over 4. And so that answer is square root of 2 over 2, negative square root of 2, square root of 2 over 2. Or that's the point on that angle on the unit circle, and I'm looking at the x value, so I put 0.7, and then the last one is 2 pi, which is this, so it's 1 again. Cosine is an even function, which means that if you have the positive version of an angle, it's going to give you the same answer as the negative version of that angle. So if I would do cosine of pi over 4 and I get 0.7, then cosine of negative pi over 4 is 0.7. If I do cosine of pi over 2 and I get 0, then cosine of negative pi over 2 is also 0. If I do cosine of 3 pi over 4 and I get negative 0.7, then cosine of negative 3 pi over 4 is also negative 0.7. And then I'm just going to do that all the way through. So for negative pi, it's going to be negative 1, just like it was for pi. For 5 pi over 4, it's going to be negative 0.7, then 0, then 0.7, and 1. Alright, now I have all my points that I'm going to plot on this graph. So I'm going to start with the x-intercepts. Those are the ones where our output is 0. And so those are at negative 3 pi over 2, negative pi over 2, pi over 2, and 3 pi over 2. And I'm going to plot those. So I have negative pi over 2, negative 3 pi over 2 on the left, and then pi over 2 and 3 pi over 2 on the right. And if the pattern would continue, I would also include 5 pi over 2. Then I'm going to look at the ones, my maximums and minimums. So I have 0, 1, pi, -1, 2 pi, +1, negative pi, -1, and -2 pi, and +1. And I'm going to plot those on my graph. A cosine is also going to be a wave graph, so I can connect these in a wave. I'm starting at 0, 1. So unlike the sine graph, I'm starting at the maximum on the y-axis instead of the origin. And then pi, I'm at -1. At 2 pi, I'm at +1. At negative pi, I'm at -1. At -2 pi, I'm at +1. And this is what I'm going to see when I connect these. I'm going to connect them in a wave. And this is what the wave is going to look like. And it goes on and on forever. And if I were to put in the points with a reference angle of pi over 4, and I put these in, then I would see that they were on that wave that I created. I could have done them first, like I did in the sine graph video, and I would have seen that the points are on this wave, and that's what makes it a curve instead of straight lines up and down.